Page 2, here we go. 3 variables by hand. So something I have found helpful is make sure you're labeling. We have A, B, and C are 3 different equations here. And we want to look for the easiest way to eliminate one of these variables. And right away what pops out to me is I have a positive z and a negative z. I don't have to multiply these 2 equations by anything. I can just add these together and eliminate z right away. Okay, so I'm going to start out with A and B. So if I just add these together, I'm going to get an answer of 3x plus y. My z's are going to go away, and I have equals negative 5. Okay, then I need to try and figure out another easy way to eliminate z, and what equation might be the easiest to look at. So now I have a negative z and a positive z. So now I'm going to take a look at B and C. But what I do need to do is I need to multiply B by 2. Okay, so I'm going to multiply every single term by 2. So 4x plus 6y minus 2z equals negative 8. And then I have C, which is negative 3x plus y plus 2z equals 13. All right. So here we go. We have x plus 7y. Goodbye z's equals 5. Okay, so here we go. Now this is my D. This is E. So I'm going to take these two and I'm going to try and eliminate something. Something that might be easy. Well, both of them have just a single variable by themselves as one of the terms, so I can really just multiply by negative 3. So that's what I'm going to do here. Okay, I'm going to look at D and E. And I am going to multiply E by negative 3. So I have negative 3x minus 21y equals negative 15. And now I'm going to compare that with D. So I have 3x plus y equals negative 5. So here my 3x, 3 and positive 3x, those go away. And I have now negative 20y equals negative 20. So y equals 1. Okay, and I'm going to take y equals 1 and I'm going to plug it right into E because then I can get x by itself real quick. So here I have x plus 7 times 1 equals 5. So x is going to be negative 2. All right, in my final step, I'm going to take x and y and plug it into my first equation here. And you can choose any, though, to solve for z. So x is negative 2 minus 2 times 1 plus z equals negative 1. So negative 2 minus 2 is negative 4. So z is going to equal a positive 3. All right, so my final answer here is negative 2, 1, 3. All right, so it's almost spring. Mrs. Powell is planting her potted plants for the back patio. After some research, she discovered that she can get geraniums. So right away, I'm going to start labeling this. That's going to be X for $2.25. Dahlias, which will be Y for $3.22. And poppies, Z, for $1.84. She has decided that she would like 5 times, and I'm going to underline this, it's going to be something that we're going to look at, 5 times as many dahlias as geraniums. If she is planning to buy 44 plants and spend a total of $126.62, how many of each variety will she buy? Okay, so we have 3 different ideas here. We have a variety of plants. We have a certain amount of geraniums, a certain amount of dahlias, and a certain amount of poppies. But we're going to come up with a total of 44 plants. So the first equation is our basic, I'll change this to blue. Here is x plus y plus z equals 44. Okay, then we're looking at, we understand that each plant costs a certain amount. But total, this is how much she's going to spend. So now we have an entire equation related to money. So geraniums, I have 2.55x plus 3.22y plus 1.84z will give me a total of $126.62. And then the last equation, I have 5 times as many dahlias. Dahlias is y, as geraniums. Geraniums is x. So you have to ask yourself, what is the larger number here? So she's decided she would like 5 times as many dahlias. So she wants a lot of dahlias. So that's going to be by itself. And now when we're writing this equation, this statement has to turn out to be true. So if this is the bigger number, what do we have to do to geraniums to make sure that this is equal? We have to multiply that by 5. So these are your 3 equations, and you can use your Lovely Inspire to plug everything in, and you should come up with an answer of 6, 30, and 8. Okay, so we're going to start to get into the linear programming, and it's really important to understand how to read the graph. And it's not showing up very well on here. Hopefully your actual review looks better. But what you do need to do is make sure that you isolate y so you can understand how we're graphing these. So here we're going to have y is less than or equal to negative 1/2 x minus 2. And this equation is going to turn into y is greater than, and that's because we're going to end up dividing by negative, which is going to switch our sign. So greater than 2x plus 3. Okay, and I know that this is going to be a solid line, this is going to be a dotted line. So my solid line, I'm going to start down at negative 2. It's kind of going to look, okay, that's dotted, that's down at negative 2, that's not working. Okay, this line is down at negative 2. That's solid. So right now it's between B and C. Okay, my other line is going to be up at 3. So now I got to really just kind of focus on the shading here. So where I'm at, ooh. Okay. Sorry. Malfunction. Okay, so I'm down at negative 2, and my slope is negative. So we're taking a look at this line here. We're going down 1/2. So this is working out great. And it's less than, which means my shading should be going this way. My other equation, I'm going to be up at positive 3. It's up 2/1. So this looks great. And y is greater, which means my shading wants to go this way. So this is the correct shading. B is your answer. So write a system of linear inequalities that have the given graph. So we want to take a look at what the slope is, and we want to figure out our shading. So I'm going to start with this line first. Okay, here we have, of course, we're going to start with y. Now, looking at this line, the shading is happening below the line. So I know right away that this is less than and equal to because it's solid. I'm starting up at 2. So I know I'm at plus 2. And then I got to take a look at the slope. I am going up 2/2, so that would just be a positive 1/1 slope. So that's my first line. Okay, the second line, it's the solid line. going to start with my y. Taking a look at this shading, it's above, which means we're going to be greater than or equal to. This one is starting up at 5. And when I take a look at the slope, this is a negative slope. I'm going down 5 over 4. So negative 5/4 x. So I'm just going to move on to the next problem, and then I'll make one more video for the programming. All right. So again, I have another graph here, and I want to take a look at these lines and make sure I understand how to graph those. Okay, so I'll start with this line. Okay, remember that we have that Vux Hoy. This is a vertical line. So it's going to be, our equation is going to be starting with x. So this equation is x, the shading, now we're thinking about all the x values, whereas the shading, it's happening going greater, getting to those larger numbers. So x is greater than or equal to 1. Then we have 2 horizontal lines. So here's one, here's the other. So if it's horizontal, that means we're going to start the equation with y. Okay, so I'm going to start down here when we're at y equals 0. But because there's shading, it's an inequality. And when we're at 0, everything is above, which is greater. So greater than or equal to 0. Up here at 2, all the shading is below it. So y is less than or equal to 2. And the last equation is an actual slope. We're starting at 4, and we're going down 2 over 2, down 2 over 2, which means it's just a negative 1-to-1 slope. So y, negative x plus 4, and all of the shading is happening below the line, so it's going to be less than or equal to. All right, last video is going to be on the linear programming.